Now let's have a look at the history of databases. So, databases started as soon as people could count. I'm sure, granaries in old biblical towns, Nineveh or whatever, they had so many sheaves of wheat, so many hectares of corn, and were stored here, so many were stored there, and these things were written on clay tablets in cuneiform or whatever. Those were databases. If a caveman or a woman drew 12 bisons or something on the wall, maybe that's because they were starting to herd 12 bisons. Anyway, more recently, this is a copy of a page. I'm sorry it's not very legible, but I hope you get the idea. It's the 1920 U.S. Census, and it was handwritten. I bet you it was a lot of pages. So ultimately, what could you really do with this information? How would you figure out what percent of a certain zip code was of Asian origin or, whatever? Kind of hard to do. You had to do it by hand, obviously, and there weren't computers, of course. So this is like the opposite of digital information, that we have today. So this is how records and databases used to be kept. After that, it progressed to, with early direct mail efforts, they really were mailing lists. And people didn't have email addresses, but they had phone numbers. So they'd have first name, last name, street address, phone number, and maybe whether they bought or not would be kept in an early computer database. And that database was used to a large degree to spit out address labels so that a mailing could be addressed, by machines mechanically, and thousands, tens of thousands, hundreds of thousands of catalogs could be sent out quickly, put into the mail. By the way, how often do we do the census in the U.S.? When is the next one? What are some of the news stories about that census? Is any of you aware of that? Are you aware that the administration is evidently trying to include a question about whether a person is a U.S. citizen or not? And there's some controversy about that. Okay. Of course, we have progressed. Databases weren't updated very often in the old days. Every year, whenever. Direct marketing, as I said before, it was printing mailing labels. It was a tool for direct mail. But of course, today, databases are continually updated. Really live information being fed into the computer, in the CRM system, analyzed, learning is gleaned, and new communication can be sent out almost in real time. You know that because you see a company like, again, Amazon, when you buy something, sending out, your purchase orders confirmed, and maybe suggesting some other products for you to buy. And the power of information basically is the amount of data over the recency of data times computing power. And this all leads to something we talked about before, which is like this ultimate sort of artificial intelligence computing power. I think we've already looked at Watson. I don't think we need to do that again. But I do want to show you this graphic depiction of a human heart. Because the database isn't just a picture of a heart. It's a live, pumping, beating thing. And just the way blood goes in the heart and goes out of the heart. Information goes into the database and goes out of the database. So the database is a real-time, I guess, almost living thing. So when we say it's the heart, it really is the heart. This diagram is a basic database setup. And I'm just going to take you through a couple of points here. You've got an operational database here on the left, which captures purchases and transactions and sends information to the warehouse to pick certain products and ship them and how to ship them, and here's the address they go to, etc. And it manages payments. So basically it's an operational or a transactional database. Now that database is connected to the marketing database. And the marketing database is what really compiles information on each customer. And that's where lifetime value calculations are done, as you see there, RFM. That's recency, frequency, monetary. It's another way to segment customers. Basically says that you're more likely to sell something to someone who just bought from you or who buys frequently from you. And so it's not the same as a most valuable customer. It's just the idea of getting someone to buy again quickly, more or less. And a lot of databases do that too. Appended data, we're going to talk about a little more today, but basically, most marketers with databases go to a company like an Axiom, for instance, and give them their customer information and then see what else is known about the customers, what other databases they're in, and to try to learn more about the segments and therefore be able to better market to them, to talk to them more specifically. And marketing communication sends out emails and surveys and thanks for the business and things like that. Now, this is a classic relational database, meaning it's two databases, one that handles very quickly transactions, the other that's more for analysis and communications. They're joined together by one key variable, which is the individual customer number. So every single customer in a company's database is given a number, and it's that number that links. So if I know that Fred McGillicuddy bought something from me in the operational side and his number is 123, the operational database sends his customer 123. Here's what he bought. Here's how much he spent, over to the marketing database. Okay, and what this does is it saves space in the overall database, and we'll get into that in a little bit more detail in a moment. And it saves time too. By the way, you notice I've drawn in the website as also, sending data to the operational database, et cetera, et cetera. So that's a basic database setup. Yeah, RFM, recency, frequency, monetary. So speaking of relational databases, I'm going to get into that a little bit. Your book gets into it, which is another reason I'm so impressed with it. The other textbook I used previously did not even mention relational databases. That's a picture of is that my old car? Well, it's not my old car. It looks like my old car. It's a Subaru Outback, an old one. Okay, now, it's a little story I'm going to take you through here. You bought this car in 2002. It's 2016. Repairs are starting to add up and cost a lot. So is it time to buy a new car? Are you just having to replace the same things over and over again? How expensive is it? What's been fixed? What hasn't been fixed? Should you trade it in? How do you decide? What would you like to know? Well, I actually took all my repair records, okay, and put all those repair records into a database. And hopefully by taking you through this a little bit, you'll understand relational databases a little bit better. Okay, so This is using a program called Microsoft Access, which you cannot get on a Mac, unfortunately. So we do this in my database class, and pretty much all the students have to go on school computers, the PCs, to be able to get access, because it's the only way they can really see how this works, this relational database. So I did a basic database entry. Okay, I started a database in Access. These are the columns, okay. I could choose the column name, repair cost, and it let me input dollars, okay. The time of the repair, so there's the date of the repair. And then what company, what mechanic or garage did the repair. So I was capturing those basic pieces of data. The total amount, the date, and who did it. And you'll notice that there's a repair ID automatically given in the left-hand column. This is key because it's the same thing as the customer number. And you'll see how that works in a minute. And it's less than a minute, and hopefully you're seeing how it works. So now what I did is I took each individual repair bill and attempted to break it out into what was I paying for. Okay, so we take a repair event and break it into labor and parts, and then write down the details of what was repaired, even include the tax, so it would add up to the total amount of the bill. So I just want to go back here. So you see repair ID on the left, and then here's repair ID on the right. So this, I could basically see now 7. You see repair ID 7777. So those top 4 items, you see the 7s on the right, are encompassed in this huge bill for $537.84 on February 12, 2013 that my good old mechanic Ricky did. And there's what the total is. Okay, so now this is a second database. This is a relational database where I break out the items repaired, and it's linked to the main database, the first one I did, by the repair ID. And Access lets me pull up the 2 databases in the different columns in the databases and then link them. And there you see how the repair ID links them. Right? And then I could sum up all the parts that I bought as opposed to labor, and I can do things with the data now and that I might not have been able to do. I could pull everything Ricky did, for instance, the kinds of things he did and the kinds of things done by other places. So basically, this allows me to go in and query the database and run reports totaling different items and, It basically gives me the basic information I need to see how much I'm spending on the car, what I'm repairing, etc. So the relational database is 2 or more databases linked together by a customer number, and it's done to save calculation time and to save space, storage space too. Okay. So these are typical types of information that go into a basic customer marketing database. First name, last name, address, phone number, email, demographics, which I'm either pulling from my own survey or I'm maybe getting some supplemental data from an external source. Psychographics is probably from an external source. Obviously, transaction data are there in a relational database. Also want to make the point that databases need to be maintained, that lists and data are perishable. People move, people die, oh dear. Change is the constant you can count on. You need constant control and maintenance. And one thing that people do to maintain is what's called a merge purge, where you're making sure you don't have the same person listed 2 times, the way my public library does. I got 5 different stickers that the library's great on my refrigerator because I got 5 different pieces of mail. We're going to stop now and pick up